Lesson 112, ratios of side lengths of a right triangle, and the appendix lesson, graph system of inequalities. We'll be looking at a little bit with trigonometry today. So definition is just a branch of math that explores the relationships between angles and sides of a triangle. And in these triangles, these would be right triangles. And when would we use trigonometry or these skills in real life? If you're doing anything with surveying, like surveying the land, navigation, engineering, working with GPS systems, they're all going to be making use of trigonometry. So the sides of a right triangle, the vocabulary words that we're looking at today are opposites, adjacent, and a hypotenuse. The opposite is always opposite the hypotenuse. And the hypotenuse is always opposite the right angle. If you find the right angle, the opposite and adjacent are your two legs. And so in this case, you're looking at focusing on angle A. Opposite angle A is the opposite side. So the angle that, or the line, the side that does not touch A. If you were doing B, angle B, opposite angle B is going to be the base of that triangle. Okay, so opposite does not touch the angle. Adjacent touches the angle. That's not the hypotenuse. So it's very important that you understand which one is the opposite, which one is the adjacent. So let's take a look at an example. It says find the ratio of the length of a side opposite angle A to the length of the hypotenuse. Express the ratio as a fraction and as a decimal. So the side opposite angle A. If angle A is here, opposite is the 3. So we need to find the ratio of the length of the side opposite angle A to the length of the hypotenuse. So we have opposite side 3, the hypotenuse is 5. So that's our fraction 3/5. 3 divided by 5 would give us 0.6. So that would be our fraction, our ratio as a fraction, and our ratio as a decimal. Next one, find the ratio of the length of the side opposite angle X to the length of the hypotenuse. So X is here, opposite is 6, the hypotenuse is 10. It says right as fraction and a decimal, we should reduce our fraction, so I can divide this by 2/2, which will be 3/5, which will give us a decimal as 0.6. And the second one, or the third one here, is find the ratio of the length of the side opposite angle R. So angle R is here, opposite is 1. The length to the length of the adjacent side. So the side that touches T. Then use a calculator to find the ratio rounded to 3 decimal places. Since we do not know the base, we don't know this part here, we know that we can use the Pythagorean theorem to figure that out. We can take our 1 squared plus, we'll just name this n squared equals our c squared, which is 2 squared. So 1 plus n squared equals 4. Get n squared by itself, I subtract 1. N squared equals 3. To undo a square, we find the square roots. So this would have to be the square root of 3. So I would have 1 over the square root of 3. That would be my ratio. Now we have to solve that. So in our calculators, we can do 1 divided by the square root of 3. This says round to 3 decimal places, so this would be about 0.577. Next, find each ratio of the lengths with respect to angle A for the illustrated right triangle, then express each ratio as a fraction and a decimal rounded to 3 decimal places. So opposite to adjacent to angle A. So opposite to adjacent that touches A, which is 2. So our decimal would be 0.5. Next one would be opposite to hypotenuse. We don't know that one, so we have to do our a squared plus our b squared will equal our c squared. And this is c. So 1 plus 4 equals c squared. 5 equals c squared. Undo a square by finding the square root. So this has to be the square root of 5. So now this would be 1 over the square root of 5. And I cannot have a radical in my denominator, so I need to rationalize that by multiplying this by the square root of 5 over the square root of 5. And now I'm left with 5 in the denominator, because 5 times 5 is 25. The square root of 25 is 5, and I have the square root of 5 on top. So I have 5 square root of 5. And so now I can take, you can either, to find the decimal, you can either take 1 divided by the square root of 5, or you can do the square root of 5 divided by 5. You'll still get the same answer, which will be 0.447. And then adjacent to A, which is touching A, to the hypotenuse, which is square root of 5. Again, need to rationalize it by multiplying by the square root of 5. So I would have 2 square root of 5 divided by 5 as our fraction. And then as a decimal, I'm just going to do the initial one. So 2 divided by the square root of 5, you would get 0.894. Next one, find the ratio of the lengths with respect to angle B. So we're looking at everything based on B. And then write it as a fraction and as a decimal. So opposite to adjacent, opposite, adjacent, which touches it, which is 1. So this would just be 2. So 2 over 1, and then you'd have 2 as your decimal. Next, opposite to over hypotenuse. This is the same as 1 that we had before, so this would be the square root of 5, just taking it from the previous example. So that would be over the square root of 5. Multiply this by square root of 5 over square root of 5. So 2 times the square root of 5 over 5. And our decimal is the same as what we had right here. So it's 0.894. And then the last one, adjacent, 1 over hypotenuse, square root of 5. Multiply this by the square root of 5. It will be square root of 5 over 5. And our decimal would be the same as this example here, which would be 0.447. And our last part with the appendix lesson, graphing systems of inequalities. So here we are going to be shading, but first graphing them like you would do a linear equation. So y equals 2x minus 1. First point is at negative 1 because that's the y-intercept. We have a slope of 2, so up 2, 1, 2 to the right 1, up 2 more to the right 1, or you go down 2 to the right 1, left 1. Now I have it, since it's a less than, I use a dotted line. So I'm just going to use a dotted line here. Next one, negative 3. Point at negative 3. I have a negative slope, so it goes down 1 to the left 1, or to the right 1, down 1 to the left 1, or I can go up 1 to the left 1. And since it's got the equal to, I can have a solid line. So I'll draw a solid line for this one. And now the shading part. For here, it says it has to be, let me use the blue, it has to be less than the dotted line. So less than means over here and here. And the other one is greater than, so it's got to be greater than the solid line. So above the solid line, so wherever I see the two colors, that's where I shade it. So this should be the part that's shaded in. Next one, over here, y is greater than or equal to x. So it's at 0, 0, positive slope. Since we have a solid line, we have a equal part, so it's a solid line. So I can draw a solid line through here. Next one, put a point at positive 1, y-intercept, a negative slope, a negative 1/2. So down 1 to the right 2. Or you go up 1 to the left 2. And it has the equal to sign, so it's a solid line. Now let's go back to where we shade. The first one, it has to be above the black line, so up here. This one is above the green line, so up here. So you can see where the two colors or the X's are. So we would be shading this part. That's where all the solutions would be. That is our lesson today on ratios of side lengths of right triangles and the appendix lesson of graphing systems of inequalities.